Hello everyone, welcome back to my channel. Today is December 17, 2025. Last time in my previous video, I talked about word2vec a little bit and we touched cosine similarity, which is used to calculate the distance between two vectors. So just a little bit recap. So basically we have two embeddings from the model and then we call this reshape 1, comma minus 1 to convert this embedding into vectors, and then call this cosine similarity function from scikit-learn. There's also this weird 0 at the end there. So those are the details that I kind of skipped in the last video. And in this video, I'm going to dive a little bit deeper into that to really understand what this reshape thing is and why do we need this like 0 at the end to get the cosine similarity there. Okay, so let's get into it. So first of all, the embedding in this case, the type is like a NumPy array there. So it doesn't have any, it's only like a one dimension there. So it's a 1D vector. However, the reason that we need to call this reshape function is to convert this one-dimensional vector into a 2D like a matrix. So that's what this cosine similarity function from scikit-learn is expected. So that's why we need to do that. So to understand this a little bit better, let's look at some example. So here I could define like A as a normal NumPy array with only 3 elements, 1, 2, 3. If we print out the shape of A, from here you can see the first dimension is 3 and it doesn't have like the second dimension. So this is just pure like a 1D array. And then what the reshape does here basically is like the first parameter, meaning how many rows do you want in the like a reshape recreated array using like A as the material. So the first parameter just means how many rows do you want. And the second parameter, like -1, is like the column. If it's a 2D, -1 just means like I don't care how many columns are there. So you figure it out by yourself, but I just want one row. So that's what happens there. So basically, you'll see after the reshape. So this reshape function is like a non-mutable function. Basically, you will not change the content of A, but instead it will create a new tensor or vector or ND array. So if we print the shape of like B, you will see this is a one row, 3 columns there. So I know they look the same. Basically a 1D array with 3 dimensions with like 3 numbers, or just a one row and then 3 columns. But I hope you can tell the difference. They do mean the same thing, but they are like this one has only one dimension. This one becomes like a two-dimensional, whatever you want to call, like an array, a matrix, or a tensor there. So now this is a way to create like a 2D and NumPy array. So you give the first row, you give the second row. So the parameter is like a list of lists. The first list is the first row, the second list is the second row. Then you look at the shape, this is like a 2 or 3 column. So if we kind of like reshape this two-dimensional or matrix into a 1D, not 1D, like just a one column, and one row, and I don't care how many column, like a tensor, it'll become like 1/6. Becomes a 1 and 6. So this is one row and then 6 columns there. So you you will see like if we print out B, let's add like a code block here. So if we print out B, you will see it just like equals to 4, 5, and 6 there. Really? No, I need to run this. So yeah, 1 and 6, and then I think it's equal to 1, 2, 3, 4, 5, and 6. Yeah, this is what B is. Basically, this is still like a 2D array with 1 row and 6 columns there. So, and that's what cosine similarity is expected there. So let's say, what if like A and B has more than 1 row? So here they are like a 3-row matrix for A and 3-row matrix for B. Then you call the cosine similarity. This gives like also outputs a matrix. This is like a 3 by 3 output there. So how do we understand what this is doing? So under the cover, this is how things are calculated. So for like coordinate 0, 0, which is this one, this number is the zeros vector and the z of A and zeros vector of B. So this computes similarity. So it becomes a number and we'll put into this position. And then this one, which is 0 of A and 1 of B, would go to here. Basically, this becomes a 0, 1 coordinate and becomes this number. So like a special case would be like the 2. So this is 0, 1, 2, and then it's 0. So it's 2, 0, which is this one. Since they are both like 7, 8, 9, then we know they're the same vector. The cosine similarity of them should be 1 there. So this is what like this telling you there. So to recap, so like the first row of the output of cosine similarity would be like the zeros vector compared to like 0, 1, and 2. And then it becomes the first row of like becomes 0, 0's row of A compared to 0, 1, 2, and 3 of B there. So and then so on and so forth. So now we understand like the reason why we need a 0, 0 at the end. So if we go back to the special case, there's only like a 1 row in A and 1 row in B. So the first part, this is like a 1D array. Calling the reshape, turn it into like a 1 row, 3 column 2D matrix. And then call this cosine similarity. It's gonna output like a 2D matrix with only 1 row and 1 column. So the coordinate will be 0, 0. So that's why we need the 0 at 0 here to get it out. So the reason is because it's output a matrix. Although there's only one number into it, but you need to get the 0 row, 0 column out there. So that's the reason that we need to have this one. So this is just a basic use case. Why the function is designed in that way is just because like you can, instead of like comparing like each vector pair one by one, you can kind of like pass them as two matrices and do sort of like one call doing a parallel sort of like comparison. At least conceptually it's parallel, but under the cover the implementation might not be real parallel, but conceptually it could be implemented in a parallel way. So that's the reason that we need the reshape thing and we also need a 0, 0 here. to get the correct cosine similarity.